Imagine walking in a forest on a moonless night. The trees are silhouettes, the undergrowth is a sea of shadow, and then, faintly at first, you notice ghostly green lights in rotting logs and along the edges of fallen branches. This phenomenon goes by many names: foxfire, fairy fire, or jack-o'-lantern light. Ancient writers recorded seeing glowing wood. Aristotle and Pliny described a cold light that wasn't flame. During the American Revolution, glowing fungi were even used to light the needles on the compass of the turtle submarine. People have been fascinated by this forest nightlight for centuries, and it still has the power to stop you in your tracks. Among the roughly 80 known bioluminescent fungi, Panellus stipticus stands out. It's a small, fan-shaped mushroom that grows in overlapping clusters on hardwoods. The species is saprobic. It helps rot logs and produces a faint green luminescence along the edge of its gills. Less than 10% of the light comes from other tissues. In New England, it's called the bitter oyster, and bitter it is. It's considered non-poisonous, but too acrid to eat. A cousin, the jack-o'-lantern mushroom, Omphallotus illudens, has bright orange caps by day and glowing gills by night. These, nature's glow sticks, might look like party favors in the woods, but they aren't safe snacks. So why do they glow? The glow is the visible part of a chemical reaction. Each bioluminescent fungus has a light-emitting molecule called a luciferin and an enzyme called luciferase. When oxygen and water are present, luciferase catalyzes the oxidation of luciferin, releasing light. In fungi, the luciferin is derived from hispidin. A specific enzyme converts hispidin into 3-hydroxyhispidin, the luciferin. A second enzyme then catalyzes the oxidation that produces the bluish-green glow. Without both enzymes, the mushrooms remain dark. In Panellus stipticus, investigators have isolated precursors like pannel and demonstrated that when these compounds react with iron-2 and hydrogen peroxide, they emit light through a chemiluminescent reaction. It's basic chemistry, yet the result feels magical. As for why the fungi bother, no single answer satisfies everyone. One practical theory is that the glow lures insects and other arthropods to the fruiting bodies, helping the mushrooms disperse their spores. In forests with dense canopies, wind dispersal is unreliable, so recruiting beetles, bugs, and flies makes evolutionary sense. The idea is supported by experiments showing that illuminated models attract more insects than dark ones. Another hypothesis holds that the glow protects tissues from oxidative damage or simply dissipates excess metabolic energy. Some species glow constantly if enough oxygen and water are available, suggesting the light may be a byproduct of metabolism. It may even serve as a subtle signpost for predators. Researchers have watched spiders lying in wait on glowing mushrooms and catching insects that fly towards the light. Whatever the function, the effect is hauntingly beautiful. On a new moon night, if you turn off your flashlight and wait, the cold glow of foxfire can make the forest floor look like a starry sky at your feet. These living lights remind us that the natural world still holds surprises. They also caution us to respect that world. Don't pop glowing mushrooms into your mouth just because they're pretty. Instead, appreciate them for what they are: ancient organisms turning chemical reactions into ethereal green lanterns, a biological wonder you can see with your own eyes if you're willing to step into the dark.